So in yesterday's session, when we started with the collections framework and all these concepts, the basic criteria we understood is like each uh, interface out there, like a set, list, or a queue, have its own specific usage. Like when I say usage, the main criteria is like depending on the business scenario, we go ahead and use that specific uh, collection object. Okay, so yesterday if we notice the way we used this array list object, we noted or we understood a few properties of this array list. The properties that we understood yesterday are like elements are ordered, which means the way I give the input is exactly the same way I get the output back. Okay, the next thing is stores duplicate values. When I say stores duplicate values, it means an array list can store values even if they are repeated. Okay? Now the next concept can also store multiple null values. That is what we saw, and we also used something like a for loop, a simple for loop that we know to print those values. Okay, now the next thing in this scenario, what we will understand is we'll try to see how we can loop over an array list using the iterator concept and an advanced for loop. Okay, so first let me show you the advanced for loop. Before I explain the concept of advanced for loop and how we can use on an array list, I would like to show a different example for an advanced for loop, and then come back to this scenario. So let me go back to a package where we've created some strings. So here I say main method. One second, it's stuck. Okay. So here let me initially create a string array. Arr equal to new string of 5. Okay, 5 string elements that I want to create. And the next thing is like I want to assign ARR of 0. Let me do one more way. Like let me just assign the values directly. Like we all know that there is a specific way where we can do this. Like okay, I've created an array of strings. Now the next scenario is I want to print the value. So using a simple for loop, I can say for int I equal to 0, the way which everyone knows, I less than ARR dot length I plus plus. The index starts from 0th index, so I test this out. So it prints all the 4 values: Raghu, Naveen, Ram, and Matt. Okay, that's fine. That's a simple scenario. Well and good. Now the next scenario that I'm going to explain here is like how I can use an advanced for loop concept. So when I say advanced for loop concept, in this scenario, you will never ever see, means in the next concept that we're going to see, you will never ever notice the way like incrementing, searching for the max length and initializing is whatever you did at line number 9, like initializing and looking for the length and increment. You will not do the same thing in an advanced for loop. The advanced for loop will take care of it automatically. Okay. Now, the next scenario that you need to understand here is like for means the concept is very simple. So I say for string, I will explain the concept. Okay, so in this concept, I'm going to explain a simple scenario like ARR is an array on which I want to iterate. Okay, then string is the type of output which I get from ARR. Then st is nothing but a temporary variable that you want to give. Okay, so st is a temporary variable that you want to iterate on. So the first thing is, in this advanced for loop, you need not worry about incrementing the loop or initializing or checking for any conditions. So the basic criteria here is output type, temp variable, then object to iterate on or loop on. So first one, what is the output type? If I want to iterate or loop on this array, and if I want to retrieve elements one by one, I will be getting back a string object. So this is a string, this is a string, so this is a string, like that. Every time I get a string, so the output type is string. So this is the output type. Then a temp variable. It can be anything, A, B, C, D, ST, STR, anything. So that temp variable can take each element at a time and object to loop on. So I want to loop on this ARR. So if I place a debug point and explain you how to debug it. So it is here now when I say F6, so what happened? ARR initially, if you notice, it has 4 elements: Raghu, Naveen, Ram and Matt. Now when I looped in for the first time, it removes Raghu from it and places it in ST. Now if you see ST has Raghu in it. So it prints Raghu, the first one. Okay. Then again for the second time when I iterate, ARR has 4 elements. It has already printed Raghu. So the next element it pops out is Naveen and it places it in ST. So now if you see ST, it is Naveen. So the same way, so now it prints ST. The same way it prints Ram and then Matt. Okay, clear? Now since the array is done, it comes out of it. So in this type of declaration, you need not worry about initialization or checking for a condition or increment or decrement operations. All you need to understand is what is the main object that I want to iterate on, ARR. Then what is the type of output that I get when I iterate on that. So since that is a string array which can store strings, the output would be a string. Then you can write here any temporary variable name. So all you need to do is just print the temporary variable so that it can show you the output. Clear with the advanced for loop how to use it? Increment, decrement, everything is taken care by the for loop itself internally. Okay. Yeah, means see, the advanced for loop in this, don't look for a scenario where you want to increment +1 or +2 or +3 or +4, but think at a higher term or at a bigger picture. The bigger picture is you need not worry about initialization or checking for some conditions or increment or decrement operations. Ideally, in a happy path, you look for an increment scenario where you want to print the next one, next one, next one. You want to iterate on something where you don't want to worry about all those initializations and all. So that is where you use an advanced for loop. Clear? Okay, that's good. Now, the next scenario here is I would like to take the same old concept and explain it with an array list. Now I go back to demo, and here these are the three things that we understood that we need. Okay, output type, temp variable, object to loop on. Now, the first thing, can someone tell me what will be the object that I want to loop on? LST, very good. So LST is the object that I want to loop on. Then maybe I just forgot to explain this. The column there is read as in. Okay, so if I go back to the previous example, for the output type string st in arr, that is how we read the syntax. The column is read as in. So now the next question, what is the temporary variable that I can use here? Very good, we can use anything. Okay, so I can say abcd, that's a temporary variable. Now the next one, when I loop on lst, what is the output type, or what is the type of output I get back? List is wrong, object is right. Remember here, if I go back to this example, what exactly I can store in this ARR? I can store only strings in ARR, which means ARR can store an input of type string. Now, in demo.java, when I created an LST at line number 10, what is the type of input that I can store in LST? The type of input I can store is any object, right? So many people get confused. It's not confused, but they think that LST is of type list. So the input and output would be list. It's not, the input and output is of type list. This LST is of type list, but it can store objects in it, any kind of object. So the output would be an object. So what is the one that I need to print in this sysout statement? Anyone? ABCD. Okay. So now if I run this, did you notice here the elements in the list are here 25, 14, null, maybe again all these things are being printed. So is line number 42 clear to everyone? Okay, that's very good. So it's very simple concept. LST is what I want to iterate on, and when I iterate on LST, it gives me back objects. So object is the output, and ABCD is what is the type of output that you get. Okay. Sorry, ABCD is the temp variable which stores the output. Okay. Now the next concept is, again I will show you one more different way of iterating or looping over this list LST. Okay, which can be done on this array list and all. So the next thing that we are going to see here is the very basic concept, again looping, but in a different way, right? See, let me write the syntax first and then let me explain the concept. Okay. Iterator. Iterator is an interface in Java. Iterator ITR is whatever I'm trying to write here is a standard set of code that you will be writing. Iterator ITR equal to on what item you want to iterate on. What is the answer? On what item you want to iterate on in this current class. LST, very good. LST dot iterate. Okay. Dot iterator. Iterate right here equal to lst.iterator, and since iterator is an interface which is not present in the current package, what I do is I will import it from java.util. Okay, I say import, error is gone, I save the program, go up. Can you notice here it shows java.util.iterator. Okay, now the next scenario, the next line. Once I get an iterator, then the next statement that I make is while iterator dot has next. Has next is something called as a boolean variable which shows like a boolean method which returns a boolean value, which means that it checks if the iterator has any elements or not. So to put it in a simple example, I can say like let me create a simple array list. So this is your array list. So you have n elements in it. So now when I say iterator ITR, what exactly ITR will do is if the array list uh, starts at location 2000, okay, then ITR will be pointing to the first location. Okay, it will be pointing to 2000 location, means it is like it is present here, or ITR is pointing to this location. Now you will be checking, hey, ITR dot has next has any element or not. If suppose if the list does not contain any elements, then the itr dot has next will return false, which means hey, there are no elements in the loop, so you cannot iterate on the loop. But if suppose if there are any elements in that, the itr dot has next will return true for us. So now in this current scenario, will this statement at line number 49, will this be true or false? Everyone, that will be true. Very good. So why? Because in general, when I'm pointing it to the first element, means first location, it has all these elements which it can see in that LST. So this is true. Once it is true, I can retrieve the next value by using, or I can just directly print out. So yes, this is out. ITR dot next. Okay, does it have a next element? Yes, it has a next element. Then give me the next element. Okay, so many people get confused, like if it is present here, many people think that if it says that next, give me the next element, they think that this is the element which it gives. No, when it is at this location, when you ask for a next element, it gives this element. Maybe the naming convention, if it is changed to give me the current element and check for the next element, if so then give me that current element, maybe sometimes it might make more sense. But here the concept is, since itr is pointing just to the initial location like 2000, then when you say next, it gives this next immediate element or the first element. Then again when you say next, it gives this element, again next will give this element. Okay, so even if I try to execute it, The element in the array list is 25, 14 null. Did you notice here? Again, it prints the same old scenario. And if I go on to the top, this output is for the iterator, and the output you see here is for the advanced for loop, and the output you see here is for the regular for loop that we are using. Okay, so is that clear to everyone, like how you can iterate on these elements and how you can print them and use them? Okay, everyone. Okay, awesome. Now the next concept that we are going to see here in this class is like I'm trying to explain the most frequently used uh, collection objects. So after array list, so vector is an old concept. Then people might ask like, hey, what is the difference between an array list and vector and all? So vector, we hardly use it. I'll explain the scenarios why, but just understand that vector is something which we hardly use. And there is something else like an link, well, we'll see linked list later, but the most frequently used is array list. Okay, so array list is nothing but a kind of a concrete implementation of a list interface where you can add, retrieve elements and do an iteration and get the elements whatever you want. Okay, so once that is clear, the next concept that I'm going to explain here is a set. Okay, set. So here the next thing that I say is set demo. Yeah, Aditya, go ahead.
Hey, so like on this iterator thing, right? So I tried, because the one that we users did is only that only goes one way, right? So I tried to do the list iterator,
Uh-huh.
and I saw two options there when I did the when I did list iterator litr equals list dot list iterator, and then it gives it two options, one with the argument and then the one without.
Is it this one you mean to say?
Say that again. I'm sorry.
So is it this generic that you're talking about, or
No, on this right here. So like, I was just trying playing around.
list iterator litr equal to, let me see the syntax that you wrote. List dot list iterate for 10. So is that the list that you,
Well,
the,
in yours you have to do lst dot
okay,
list.
lst dot,
So yeah, right there, right. So you got two options.
okay, let me look into this, what exactly does that do actually. So if you attach a source code to a program like how I explained in the previous class, you will be able to see, like, did you notice here? It shows me that what exactly it does and what is the use of this. Either you can do this or you can go into that method and see what exactly it is doing. Returns a list iterator over the elements in the list in proper sequence starting at the specified position in the list. Okay, the specified index indicates the first element that would be returned by an initial call to the next. Okay, so the basic concept here is, let us assume that you do this. Okay, so when I say list iterator, there is one more thing like iterator. There is one more thing called list iterator, where on a list iterator also you can do like while uh, litr, sorry, litr dot has next, and you can say, you can try to print that one like litr dot next you can do. And the use of a list iterator is if you want to traverse back, then you do have one more thing called litr dot previous. Then you can also say litr dot, okay, I should write this in the reverse order. Like this you can do, you can check if it has some previous element, then give me that previous element, like that you can do. So an iterator, using an iterator, you can traverse in only one direction, but using a list iterator, you can traverse in both directions, like forward and backward. Okay, so that's one concept in list iterator, using has next and has previous, next and previous. The other concept is like what you just asked me, like what if I give something like 4 here, okay, which way you can pass some number. Means the concept here is, if I don't give a number, then list iterator can traverse or can loop on this LST object starting from 0th index. But if I say number 4, okay, if I say number 4, just read the documentation. It shows that it can start the iteration from that position. So when you say some index, okay, when you pass some index, it shows returns a list iterator over the elements in the list, okay, which means from LST it will give us in proper sequence starting at a specified position in the list. Did you notice here? If I don't pass 4 here, then it starts from the 0th index. But if I say 4, then starting at the specified position in the list, that is where from where you can start iterating on that. The specified index indicates the first element that would be returned by an initial call to next. So is that clear? Okay, yeah, as simple as that. So there's a reason why, like, always try to attach the source. And if suppose if I share this program with you, if you want to understand what exactly this method is doing, just put a cursor there, and you can do control space. Okay. So once you put control space, just press right arrow. So did you notice this is what I'm just trying to use? Then it shows me the source attached to it, like what exactly is the functionality which this method does. Okay, the same way, like if it is an iterator, you can look for what exactly the iterator is doing. Returns an iterator over the elements in the list in proper sequence. Okay, and returns an iterator like that. So this is what you can understand from this source that is attached to you and from Eclipse content manager. Okay. Okay, yeah, that's good. Now moving on, the next example that I just want to show here is, and sorry, before I show that example, I just want to clarify and make it clear once again, one last time to everyone, that the elements are ordered, and it can store duplicate values, and it can store multiple null values. Why I am stressing upon these things is, in interviews people will ask you, hey, if I want to store elements in an order and I want to store even duplicates, then what exactly is a collection object that I can use? Then you need to say that you will be using an array list. Okay, why not vector? Vector is used in specified scenarios, but nowadays we use mostly array list. I will explain the concept later in tomorrow's class, like why, we'll see, like how vector can be used or how array list can be used. Okay, so the next concept we are moving into is a set. So in this example, I would like to explain two concepts, like two concrete implementations of a set. One is a hash set, the other one is a tree set. Okay, how the features are. Now the first one, I say set equal to new hash set. Okay, so again I will be importing the interface set and the concrete implementation class hash set by using control shift O shortcut. So notice here it prints all these things. Okay, now once that is done, the next thing that I'm going to do here is trying to add elements into set. Set dot add 1 2 3. Then I say set dot add 1 2 3. Then I say set dot add abc set dot add. I'm adding some random values. Just like this, you can add multiple objects into it, as many objects as you want, and even I can create some null value and I can add something. String f1 null. I say here set dot add f1 set dot add sy. Okay. Now a quick question to everyone. Let us assume that 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements I have added here. Okay. Now, if I add 9 elements into an array list, what will be the size of array list? Very good. The answer will be 9. Now, if I say if array list size is 9, what is the index range that I can access the elements from and to? 0 to 8. Very good. Now, the next question is, if in yesterday's class, if you remember, we just discussed at a high level that a set is or a set has features where it cannot store duplicates. My first question, does the set in the current example has any duplicate elements or not? Okay, very good. The answer is yes. Now my next question, what will be the size of set is my next question in this current example 6. Okay, now this out. Set dot size. Okay, now if I go ahead and execute, before I execute I just want to give you a heads up, like 1 2 3 is repeated twice, so one of them will be removed, and then student object is removed, is added twice. So let me run it. See, the output is 7. Okay, so when I say 7, it shows this is a total of 9 elements are there. 9 elements, this and this are removed. Okay, but still if I try to print them, okay, let me do one thing. I'm just going to I'm going ahead and trying to print all the elements, and I no longer use a simple for loop. From now onwards, I use an advanced for loop to print it. Okay, so for everyone, tell me the syntax here. What is the output type here? Let me bring my chat. Okay, our object is that. So the output type is object is right. So I say object obj in set set. I say this out. The elements in this set are set. Oh, sorry, obj. Okay. Now if I try to print it, means the only reason why I try to print this one is to explain the scenario, like some of you told 6, some of you told 7. So here if I execute this program, the output would be 7. Why? Because many people might think that the student object is duplicated or it is repeated, but the concept is student object is not duplicated. Why? Because that's entirely a different concept that we will see later. But for time being, just understand that these two objects which I've added at line number 16 and line number 17 are completely different. Okay. Now the next thing here is 1, 2, 3, which I added at line number 12 and 13. One of them is duplicated, so it is removed, and then multiple null values, they are also removed. Only one null value is stored. Okay. Now just notice the output order: null, Raghu, ABC, student, machine, and 1, 2, 3. If I execute again, okay, it's in the same order. 1 second. So sometimes what happens is, like when you have multiple entries, like a huge data, then the order is not in the same order every time. Why? Because sometimes you see null Raghu ABC, sometimes you see null 1, 2, 3 ABC Raghu student machine, or sometimes you see student ABC Raghu null machine 1, 2, 3, which means the way it prints the elements is also not in an order. Okay, it prints some random stuff every time. So the first thing that you need to understand here in this concept is, for a set cannot, I'm talking about a hash set. Okay, cannot store elements in order, then cannot store duplicate elements, then cannot store multiple null values. Okay, so anyone has any doubts from 23 to 25 in these features? Okay, that's good. Now the next question, yeah, means new student, that's what I just told. New student is a completely different concept. Like why the student object is not duplicated, that's the completely different concept. Why? Because it's not being duplicated there. I will explain that reason, but not in today's class, in tomorrow's class. Okay, so for timing, let's assume that that's not a duplicate object. uh, now now the next question: if the elements that I add into an array list, understand my question, if I add 9 elements into an array list, then I know that the index locations start from 0 to 8 if I want to access the values. Now my next question: if suppose if I want to retrieve, or if I want to get the elements from a set with 9 elements, when I add into it, is there a guarantee that the index will be from 0 to 7 or 0 to 9 or anything? Can you tell me a specific index location? Very good. The answer is no. We can never ever guarantee the size of a set, right? since we can never guarantee the size of a set, like means when I say guarantee, it means like if I add 9 elements, you can never guarantee that the index location will be from 0 to 8, right? The same way, even if you add 100 elements, you cannot guarantee that 0 to 99. So that is the reason why there is no property called get in set. Okay, you cannot use set dot get. Why? Because in an array list, since it's of fixed size, you know that. So for adding, you use add, and for retrieving, you use get and tell a specific location. But in a set, you cannot do that. Okay, set doesn't have a property or a feature called get. That is the different that's difference between an array list and a set. And apart from that, these are all the features which it differs from, like cannot store elements in order, cannot store duplicate elements, and cannot store multiple null values. Okay, so now moving on to the next concept in set. So first we saw hash set. The next thing that we'll be going to see is a tree set. Okay, now I say set. See, understand the concept here. I'm trying to do coding to interfaces. So on the left hand side, set is an interface or a parent interface for hash set. And also, if you see the diagram, the set has hash set, and tree set also is below the set, which means tree set also implements a set. So I'm just reusing the same old variable that I've created at line number 11, saying that set equal to new tree set, a polymorphic behavior for the set variable. Okay, now let me import control shift O for the tree set class. Control shift O. Look at line number 5. It shows java.util.treeset. That's fine. Now to this treeset, I want to add some elements into it. So I say set dot, means the same old concept I can do. So whatever values I've added here, I'm just trying to again add all those values to this one. Okay. Now understand that here when I say set equal to s1 and all these things, so we know that there are 7 elements which are present in a set, but here I'm reassigning set to new tree set, which means this set will lose by the time the line number 36 is executed. All these elements will be lost. Okay, lost means the set will no longer point to these elements. It will be now pointing to a fresh tree set where it will have 0 elements. So from there again I started adding all the elements again. Okay, now let me try to print the size of a tree set and then print the same old stuff. Okay, just let me write this out here. Print some space. Now let me put a debug point at line number 35 and debug it. So till line number 35, if you see, this is the old concept that we are discussing till now, where it prints the 7 elements size and then all the 7 elements. Now it prints a space, then set equal to new tree set. So does set contain any elements now? Now set became all empty. Okay. Now let me just do it once again. See line number 35, this all the elements are printed. Now if you inspect a set, set has all the elements, null, Raghu, student, all the elements, it has all the elements. Okay, now now see here, I can show you one simple example. Did you notice in the previous example, it means before I wrote this tree set, when I tried to execute the program and when I tried to show you the output, I told that every time the output might not be the same. See here, in our previous example, it was null, Raghu, ABC, and then the student object. But see here, the order has changed. Null, Raghu, student, then ABC, then student. Okay, so every time you try to execute, sometimes the functionality changes. Okay. So now till 35 it is clear to everyone. Now when I say set equal to new tree set, all the elements in the set are gone. Now it's a fresh set reference variable pointing to an empty tree set. Now, what is tree set? Tree set is again a concrete implementation of a set interface. Now, I add elements 1, 2, 3. I add all that stuff. I add. Now, see here. I just want to show you something like when I say at line number 37, I add 1, 2, 3, and 38, I add 1, 2, 3, and maybe let me add a few more here. Set dot add of 45 and one more value. Set dot add of 31. Okay, some random values I've added. Now, if I again try to debug, I'm not interested in explaining anything above line number 35. From line number 36, what is here? 37, good. 38, good. 39, good. So if I see set, it has 45 and 123 as expected. Why? Because since 123 is repeated twice and set cannot store duplicate values, so it has eliminated one of the entry. So the ultimate values that are being stored here till line number 39 is 45 and 123 only. So now when I say line number 40, when I execute line number 40 and see the output, it shows, one second, it shows 31, 45 and 123. That's fine, well and good. Now see here, understand what happens when I try to complete the execution of line number 41. So when I complete the execution, it went somewhere, but when I try to complete the execution of the program, it is throwing me an exception like class cast exception. So why a class cast exception is thrown, or where exactly it is being thrown? A class cast exception is being thrown from set demo.java class from line number 41, which is nothing but set.add of abc. That is where it throws. Now, if you go back and understand the specific error message that it is throwing, it shows java.lang.integer cannot be cast to string. Okay. So what exactly it shows is, or what exactly is from this, the understanding that you need to get is, if in a tree set, if I start adding elements, like these are all integer values that I added initially. So tree set has certain features in Java. The first feature is, for a tree set, it can store only similar type of objects. So when I say similar type of objects, then initially when I store an integer, then the tree set expects all the elements to be integers only. So adding till 31 is good, but at 41, when I say ABC, yeah, I'll come to that point side. So when I say ABC, it is not a integer, it is a different type string. So it is throwing a class cast exception. Trying to convert one class into the other is not possible. So that is a class cast exception that is being thrown here. So the same way, even if I remove this and put it here and try to execute this, even now it will show an error at line number 41 saying that, hey, I cannot convert the student object back into an integer. See, again a class cast exception will come. It shows com.easylearn java.collection framework student cannot be cast to this comparable. Okay, so the basic understanding that you need to get here is, when I add elements in a tree set, if the first element is an integer, it only expects integers to be part of that tree set. The same example, if I say like, if I do this, can everyone tell me at what line number will there be an exception in tree set? 41. Okay, wrong. 39. Very good, excellent answer. 39 is correct. Why? Because now in this current scenario, what is the first element type that I'm trying to add into a tree set? It is string. Okay. One thing that everyone needs to understand is the answer string is right. But when I say set dot add, it basically expects an object. When you store an object, it can internally understand what is that object of type. So the object is of type string. Okay. So now it is expecting a string. So if I debug it in, if I run it in debug mode, line number 36, good. 37, good. Now 38, good. So if I go to set, it stores ABC and Raghu. Then if I try to execute line number 39, something went wrong. So again, class cast exception in this scenario. Okay. So is everyone clear with this concept? Like what is happening in a tree set? Okay, that's good. There are more functionalities that we need to understand on a tree set, but this is the basic stuff. So let me comment out these things which are inappropriate at this moment, which means I cannot store all those. Yeah, the same thing, Ravi. Like even if you add null, it only expects null values. Okay, something like that. Yeah. Now, the next concept here is when I try to execute this, I store 123, 45, and 31. And if you notice, if you go back and see the set, did you notice here the tree set has sorted the input by default, which means all the input elements that you try to store in the tree set will be sorted by default. Okay. So 31, 45, and 123. So if I print it, the size of a tree set will be 3, as we all know. Why? Because it has eliminated the duplicate element 123. And if I try to print all the elements in the previous scenario, we can never expect the type or the order of output for a hash set. But for a tree set, you can always expect the type of output in which order it comes. Why? Because in a tree set, the input elements are sorted. Okay. So if I complete the execution, see here 31, 45, 123. If I add here set dot add of 3, okay, and try to run it. See 3, 31, 45, 23. The same way. One last scenario, set dot add of 1. So by default, the elements are being uh, stored in increasing order. Okay. So tree set, it can store only similar type of objects, and it sorts the elements by default. Okay. So this feature you cannot get it in a tree set. Okay. I think I just told, yeah, we can specify the order in which we want to store, I guess, but I think we need to do some custom sorting, I guess so. But the default behavior for a tree set is like incrementing increasing order. I guess we can sort it in a decreasing order. Maybe let me check that one. Okay, I'll get back to you. So it is something like an array with sorting functionality. Yes, that's correct. But the stuff here is like array will not increase dynamically in size. A tree set and a hash set can increase dynamically in size. And there is one more mistake that I just forgot. I told you that in the previous scenario, like someone was asking me if I can store some null value into a tree set. The concept is we can never ever store a null in a tree set. Okay, tree set does not allow a null value. So if I try to store, I guess it will not allow tree set dot add of S1, and if I try to debug it, 37, yeah, a tree set null pointer exception is throwing, right? In a tree set, you can never store a null value. Means I just forgot and I just told to someone has asked a question like, can I store null values or is it the same concept with a null? I told yes, it's the same concept with null, but tree set will never store null values. Okay, so cannot store null values. Now the next concept here is like in Java at any point of time, whenever you can see a tree set or a something which starts with a word called tree. Okay, by default it means that it is sorted in Java. Yeah, that's correct. That's what I'm about to say. Like you take any collection object here, like set, list, queue, map, or anything. All these things grow dynamically in size. Okay. Now it cannot store null values, and by default at any point of time if you see a keyword called tree, it means it sorts the input elements. That's the first thing that needs to come to your mind. Okay, so now some simple scenarios or basic scenarios that you need to understand. Sometimes people will ask like, hey, can you go back and try to sort elements based on some input type? Means basically the answer will be something like, sorry, the question will be something like, if I have 10 elements and if I want to sort all the 10 elements, okay, I give you 10 elements, you store it in somewhere and sort those elements for me. So which collection object you will prefer? Will you prefer array list or a hash set or a tree set? So everyone says that it's a tree set, right? That's good. But now the concept is, if you have a huge data that is incoming, then what is the specific data structure? What is the specific object, collection object that you prefer? Do you still prefer a tree set or a hash set or an array list if you want to sort the stuff? Hash set. Okay. Why hash set? Hash set is never sorted. I hope you understand that. So someone say it's a tree set, but the answer is it's not a tree set. It can be either a hash set or, but maybe problem with duplicates. Tree set. Okay, I'm not sure like what exactly do you mean by duplicates. In a tree set, you can never ever store duplicate elements, right? So if you want to sort everything, you remove all the duplicates and sort it out, something like that. Or if you want to keep them unsorted, it's a different scenario. Now, the concept that I'm trying to explain here is, in a tree set, now if I try to debug this program and try to explain this scenario, so what is the first element? 3, and then 123, and then if I execute it will be 45. Now you think that it is 3 and 123, well and good. Now if I execute line number 41, then it is 45 is inserted into tree set, and if you see here 45 is inserted between 123 and 3. Why? Because in the previous scenario it was just 3 and 123. Now 45 is inserted in between them on a sorting order. Now what happens in this scenario? When a new element, I'm not only talking about 45, any new element which is trying to add or which is trying to come into this tree set, what exactly the tree set does is it checks where exactly that element fits in this specific series. Now, since it fits in between 3 and 123 in the current example for 45, what it does is it shifts 123 to one level right and then inserts 45. Now, if I execute line number 42, now I'm inserting 31. Where will 31 be inserted? 31 will be inserted between 3 and 45. Now, how many elements it needs to shift right to insert 31? Two elements. Well and good. It's not five. It's just the two elements. So it needs to shift 123 one step right, then 45 one step right, then insert 31 in the location where 45 used to be. Okay. Now the next question. When I execute line number 43 also, how many locations all the numbers needs to be shifted for placing 1? Okay, so now all the four numbers needs to be shifted. So initially 123 will be shifted one step, 45 one step, 31 one step, and 3 one step. So all the four elements will be moved or shifted one step right, and then one will be inserted there, which means every time a new element is being added in a tree set, the tree set has an overhead of shifting the elements, right? So when the data that you want to sort is huge, never ever prefer a tree set. Why? Because it has a lot of overhead on top of it. Rather, use a hash set or an array list. Now, your next question might be, how can I do it if I have a hash set or a tree set? Okay, sorry, hash set or an array list or whatever. Now, let me take a simple example, the same old example here. Like now, let me point, or let me use the same old concept here. Without, okay, instead of tree set, I will point it to hash set. Okay. Now I say 3, 123, 123, 45, 31, and 1. Now when I try to print this set at line number 66, can someone tell me what is the order of elements it will print? I am talking about a hash set at line number 66. Order cannot be guessed. Very good, excellent. It is random order. Very good. Okay. See, it prints in random order 1, 3, 123, 45, 31. 1, 3. See, right now since the data set is very small, it just tries to print in the same order 1, 3, 123, 45, 31. 1, 3, 123, 45, 31. Okay. Means it shows in the same order every time, but that's fine. But the order ideally cannot be predicted. Okay. Now, if I want to sort it, the next thing that I do here is I use the collections class. Did everyone remember the other day, like in the previous session, I was trying to explain like there is something called as collection and collections. Collection is basically an interface that we are looking into, and then collections is a class which has some utility methods or some useful methods. So I can say collections dot sort. I want to sort the elements, and I say what exactly I want to sort. I want to sort a set. Okay. Oh, now 1 second. Oh, okay. I need to give a list here. Sorry for that. The sort is expecting an element of type list. Okay. So now what I do here is, maybe let me just make this as list arrlst equal to new array list, control shift O, import it from java.util. This is done. So now if I execute this, if I run this, okay, let me do one thing. Let me comment out line number 77 and try to print it. It prints in the same order. Why? Because it is a list and it can also store duplicates. 3, 123, 123, 45, 31 and 1 is being printed. Now I just say collections dot sort and I say an array list, then I try to print it. Did you notice here it sorts in an increasing order 1, 3, 31, 45 and 123, which means again using a simple pre-defined utility method called sort, I am able to sort all my elements instead of writing multiple for loops and trying to check for each element one after the other. Right? So now if you go back into this collections class, the collections class has a lot of methods which are predefined, and just a second, it got stuck. One of them is sort. So it can say sort, remove, peak, element, clear, size, is empty, contains, iterator, to array, to string. It should have something called reverse also, I guess. Oh no. So see here, collections. It has like a lot of methods present for it, like rotate, min, max, copy. If you want to find the least element in the collection, if you want to calculate the max element, if you want to rotate, I'm not sure like what exactly rotate is. I think maybe it shifts one location to the right, and index of any special sublist, unmodifiable list, you can create an unmodifiable list. And then it checks it reverse order, it can create or it can reverse the elements. Like that, it has something called as a frequency, which will count the number of times an element has occurred in a list. Like if suppose if 123 is being occurred twice, if you want to count the number of times the element is being repeated, then you can use the frequency method and can find out like how many times the number is repeated and all. So like that, you can use those predefined utility methods and you can use these functionalities. So what I do is you take all the elements, store it in an array list, then just call collections.sort so that the elements can be sorted for you. Okay. Yeah, if I don't want to add duplicates, that's a good question. So it's a simple way. I don't say it's a simple way, but what you can do is like hash set, or I can say set that's equal to new hash set of. Okay, did you notice here the other day when we were looking into some constructors for an array list, we discussed that it can be an empty constructor or it can be a constructor, means it's almost similar to hash set also. So I'm just explaining with hash set. It can be an empty constructor or it can be a constructor which can take in the size as input, or it can take in a collection object as input, right? So now I would like to pass. See what I'm creating. I'm trying to create a hash set. To this hash set, I want to pass a collection object as input. See, to this set I'm passing so while creating a set I'm passing an array list as input. Now if I print that, not s, set s, so see here it prints 1, 1, 3, 123, 45, 31, which means it has removed the duplicates. Now what I can say, I can convert it back into an array list. Then I can say arr lsd equal to new array list of, I will convert this set, means I will assign the values of set back into an array list again. So now what happened here, there are duplicates. Then I have eliminated the duplicates. Then I have assigned all those values to an array again. Now if I sort it, just notice here, there will not be any duplicates for me. Did you notice? 1, 3, 31, 45, 123. I have eliminated duplicates also. Clear with that? So you just need to understand like how you can use these functionalities or how you can use these elements or these objects in what scenarios. So if I want to store duplicates, what is the collection object I want to use? If I want to sort, what is that I need to use? If I want to maintain an order, what is that I need to use? Like that, you need to understand the scenario in which you want to use these collection objects and then you can use it. Okay. Any doubts till this point? Okay, now if it is clear, the next concept that we will be looking into is something called as a map. Okay, map is one more interface which is present in a collection interface, and map is not extending from collection. The first and the foremost thing that you need to understand here is in a collections framework, map is also, can you debug this sorting? Which sorting you want me to debug? Sorry.
The sorting method of which is in corrections class.
Yeah,
I
that's
mean,
right.
in what way it is different from preset?
So all these things which are like a binary classes, we cannot basically go into those classes and debug. So the concept here is if you call collections.sort and pass a list, internally it calls that list.sort, okay, and if you call this list.sort, internally the thing here is it uses a concept called arrays.sort. Okay, so all these concepts are internally written for you. So if you go into this arrays.sort, and this class is not there. Not sure what happened to this arrays class. But did you not understand here? Like they are all the internal implementations where if you dig down into step by step, maybe it's like, I don't say it's more complicated stuff, but it's you will understand that in and out of how that method is being executed or being implemented. Is that clear, or you still want to know more on that? Okay, yeah, that's good. Now, so where are we? Okay, we are here. Like talking about a map interface. So map is an interface which is in a collections framework, but it will never ever extend anything from collection. So map is a kind of a standalone stuff where it is again a specific interface. Okay, so the concept here is if you want to store some values in a set or a list, you have a specific format where you can store the values. But storing the values in a map is slightly different from what you saw till now. So if I go back to this class and say like hash map of a map. So map is again an interface in Java. So map, you cannot create an object directly, but what you can do is we can use or we can create an object of type or a reference variable of type map, which can point to a specific or which can point to a concrete class of map. So the first thing that we will see here is how we can use hash map. Okay, so I say map, which is a map which is an interface. Map equal to new hash map. Okay, Control Shift O to import line number 3 and 4 hash map and map from java.util package. Then see here how I'm going to add elements into a map. I say map dot, for all the scenarios that you saw, it's something like add, but for this scenario it is something like put. And if you notice put, the way or the syntax of this method is slightly different. What is that? It shows, hey, it accepts an object and also an object, which means it accepts two objects as input. So if I say the first object as 1 and the second object as Raghu, and I say map dot put, and in technical terms the first one is called as key, see here key, and the second one is the actual value for that key. Okay, so now if you compare this with a hash set or a list or an array list, in an array list or a hash set or a tree set, if you want to store a value, we used to store the value directly, but in a map we can store the value only with the help of a key. We need to associate a key for storing a value. Map.put 2 comma again map.put abc 555 is the value, map.top bbc. Okay, see here object and object, two objects. What is the first object called as? It is called as a key. What is the second object called as? A value. So it has a key value pair. That is what is given for a map, or that is how the elements are being stored in a map. Okay, now the next concept. If I want to get a specific value, if I want to print Naveen, then I say this is out, the value is for a specific key I'm talking about, map dot, since each value is associated with a key, if you want to get that value you need to know, or you must know the key for that. Map dot get of, I say Naveen. I'm sorry, if I want to get Naveen, I say the key is 2, so I say 2 here. Map dot get of 2. So if I try to print it, the value is Naveen. That's what it shows. Now if I print, okay, tell me the answer for this question. If I want to print hello, what exactly do I need to write? If I want to print hello, BBC, as simple as that. Use the key of hello. I say BBC. Clear? The value is hello. So first storing, use a put method and enter a key value pair. Then a get method which uses or which takes in a key. Now the next scenario, I say map dot put off 1, I say RAM, and try to execute this one. What will be the output? Will it print Rabu RAM, or will it print Rabu, or will it print both, or will it print RAM, or will it print nothing, null, or what is the output? Nothing. Okay, what about others? It will print. So what will it print? Both eyes. Okay, that's good. So okay, that's good. So the answer here is at any point of time, if you try to save a value for an existing key, then the current value, or sorry, the existing value will be replaced by the current value. Okay. So if that statement is clear to everyone, can you tell me the output for line number 19? Someone says Ram, Ram. What about others? Excellent. The answer is Ram. Why? Because for the key number 1, I do already have a value Raghu, but now again when I try to store 1 comma Ram, it checks, hey, is that key already present? Yes, it is already present. If so, go ahead and replace that existing Raghu or existing value with the new value. The new value is Ram, which replaces the existing value Raghu. Clear to everyone? So if I execute it, it prints that Ram. Okay. Now the next concept, how to iterate on a map. So this part is slightly tricky. Means when I say tricky, it's not a straightforward scenario. You need to do it. Means you can do it in couple of ways using uh, an entry set or a set or whatever. We'll look into one of the features like using a set. Okay. So the first thing that you need to do is, if you want to iterate on a map, first get all the keys which are present in the map. What are all the keys in the map? 1, 2, ABC and BBC. They are the keys present in the map, right? So the first thing is retrieve all the keys. So what I do is I'm just showing you one of the ways, which is a standard way of doing. When I say standard, means it's a regular way that we can follow one of these process. So I can say set s equal to, so I retrieve all the keys and store it into a set. So set s equal to new, oh sorry, not new hash set, it is map dot key set. Do you notice here key set, which returns an output of type set, which is present in the map interface, now returns a set view of the keys contained in this map, which means it retrieves all the keys present in the map and will store it in a set, or will give it in the form of a set. Control Shift O to import set, done at line number 5. Now because of this line, all the keys 1, 2, ABC and BBC will be stored in this S. Okay, S will be pointing to that object. Now the next thing is for object obj in S. I say this out obj. So can someone tell me what will be printed when I say sysout obj at line number 24? All the keys will be printed. Excellent. Okay. So all the keys are printed 1, 2, ABC and BBC. Well and good. Now my question is, how can I modify line number 24 to print all the values in the map. Object dot value may be wrong. See, the concept is very simple if you understand line number 20. I gave the clue also. Get off object. You're almost close. Map dot get off object. Excellent. That is what you need to do. What is this one? This one is nothing but an object, right? Which is nothing but the key. So 1, 2, ABC, BBC, anything can be given in this highlighted part at line number 20. So they are nothing but the keys. Now, do you have the keys? Yes, you do have the keys in S. And every time you iterate, that one key will be placed in OBJ. So all you need to do is map dot get off OBJ. That is what you need to do. Okay. The value for the key OBJ is okay. So the value for obj, so obj will be printed. So initially it prints, like if you go ahead and see in the previous example, when we in the previous scenario when we executed 1 2 bbc and abc, it prints. So for this 1 2 bbc abc, so here for 1 it prints map dot get off 1, map dot get off 2, like that it gets executed. Okay, map dot get off ram. So for 1 it is ram, 2 Naveen, bbc hello, abc 55. So is it clear to everyone like how things are being sorted? Clear? Okay, well and good. Now the next concept. Basically, like if I try to do same old stuff here, paste it, Control Shift F, format the code. I will not repeat it again. Map equal to, instead of new hash map, I will say tree map. Control Shift O, import the tree map at line number 28, and then I say S is already used, so I will not redeclare S. I say S equal to, okay, everything is good. Now I'm interested only in explaining from line number 28. So I place the debug point at line number 28. So now map equal to new tree map. Well and good. It doesn't have anything as an entry now. Map dot put of 1 Raghu. So I say if you inspect map, 1 equal to Raghu is stored. Then 2 equal to Naveen. So it has two pairs key value. First one 1 Raghu, 2 Naveen. Then it went somewhere, and if you see again some exception. Any guess what went wrong at line number 32? By looking at line number 28, you can get some hint. Awesome answer. Class cast exception. It is not a similar type. Did you understand here this concept? Like in the previous example when we saw tree set also sorts stuff for you, but it expects only one type of output. The first type of input is what it expects every time. The same way, if the input key is of type integer, then the tree map also expects every key to be an integer. So let me modify this to, instead of 2 I will say 3 or 4, and here I say 2, and here I say 9 and 1 again. Okay, let me debug it once again, one last time. So 1 4 is good. Now I say 2, it is good. If I show you the map, it's 1 Raghu, 2 555, 4 Naveen. And did you notice here, team, what happened? It's sorted based on the key. Very good. See, key, it has like 1, 4, 2 is the key, but it's sorted based on the key. 1, 2, 4 is what is being sorted in the tree set. Then if I execute it once again, it shows 1, 2, 4, 9. And now see here, in the current scenario, 1 is being shown as Raghu. Now if I complete the execution of line number 34, and if I go back to map, see, instead of Raghu, it is replaced with Ram. Okay. So Ram, 555, Naveen, and hello. If I complete the execution, it again prints all the values for you, 1, 2, 4, 9. Okay. So is this clear to everyone? Like, tree means sorting. Okay, either it might be a tree map or a tree set. Tree map means it sorts things based on the key. Is that clear to everyone? Okay. Yeah. The simplest scenario where you use map in a real time is uh, one scenario that I can say is like trying to store all the values that are means there is a concept of caching. Caching means like instead of every time going to the database, you can retrieve some data which will never change, and you can store it in a cache. Okay, so cache can be like a value that can be stored in memory, so that every time user requests for something, you can go to that in memory and retrieve it faster rather than going to the database. So let us assume that you do have a states of United States. So let us assume that someone selects in a website in some registration or whatever. They try to say that their country of residence is United States. So as and when you select United States, you populate all the states in this country, all the 50 states. So if that is one thing which will never change, like when I say it will never change, it hardly changes, right? There will be 50 states only. If they change, it might be like for many years once they might change. So in that scenario, what I can do is I can fetch all those things and I can store it in a map where I can say for USA, these are all the values, and for India, these are all the states. Like that, I can store key value pairs and I can keep them in a cache, in a map, and can show them to the users. So even if 100 users try to hit my application and go to the registration page, I need not go to the database every time for fetching the states of United States. Okay, why? Because it's already present in the cache. So the caching concept, and there are little more concepts, all those things are implemented using a hash map. Clear? And also sometimes when you want to store some objects based on the IDs, like if you want to store a student object based on the ID, so for student ID 1, like a key 1, this is the object, key 2, this is the object. Like that, you can store some objects also using the key value pairs. Okay, clear? Okay, yeah, that's good, team. So any doubts before we wind up for the day? Okay, if it's no, okay, yeah, means the concept looks like they're all kind of a similar functionality, but the only thing is like you need to understand in which scenario you need to use what. Okay, maybe just do a little bit of practicing on these programs, then you will get used to these things, and I can add more features on top of it actually. Okay, yeah, I'm just stopping the recording.